Here we will discuss writing Lewis structures, section 9.6 in your textbook. In the text, they give 4 steps for writing Lewis structures, and I strongly recommend that every time you write a Lewis structure, you follow these 4 steps so that you become familiar with them. Here I've only got the abbreviated versions written. Be sure to read the whole section 9.6 for all the little hints that they give along the way. The first compound that I'd like to try following these steps with is HOBr, hydrobromous acid. It's a bleach, an oxidizer, a deodorizer, and a disinfectant. It kills the cells of many pathogens. Not real common, but sometimes it's used. Now, in terms of what steps to follow, step 1 is to write the correct skeletal structure for the molecule. You've got to figure out what's in the middle and what's on the outside. And in this, they give you a hint because there are 3 atoms, and the fact that they put the oxygen in the middle gives you a little bit of a hint that it is in the middle. Normally, the less electronegative element is in the middle, and oxygen is the most electronegative of these 3. But H, since it only wants 1 more and can only have a maximum of 2 electrons, is always on the outside terminal. And mostly the halogens like Br, F, Cl, they have 7 valence electrons. They only want 1 more, so they only usually make 1 bond. They tend to be terminal on the outside as well. So our skeleton is going to be H and O and Br. I'm going to put the O in the middle. The next step is to count up the total number of valence electrons. You add them up as they come from each atom. Hydrogen comes in with 1 valence electron, oxygen with 6, and bromine with 7. So HOBr has a total of 6 plus 1 plus 7 is going to have a total of 14 valence electrons to work with. Next, we're going to distribute the electrons among the atoms, giving octets, or for in the case of hydrogen, a duet. And they suggest that first you make single bonds sharing 2 electrons. So H and O could have a single bond sharing 2. O and Br could have a single bond sharing 2. That uses up 4 electrons, so we have 10 left. Now everybody's at least connected together by 1 bond. Next, we add the lone pairs. Remember, electrons tend to come in 2s because 2 electrons can fit in each orbital. Hydrogen is already sharing 2. It's good to go with a duet. Bromine, however, and they suggest that they add lone pairs to the outer atoms first, has sharing 2 right now, so it needs 1, 2, 3, 4, 5, 6 to have a total of 8. Now I've used up 6 electrons, so I have 4 left. Oxygen is sharing 1, 2, 3, 4, so it needs 1, 2, 3, 4 more to have 8. That takes care of all of our electrons, gives everybody an octet, and that is the Lewis structure for hypobromous acid. You might notice that we never got to step 4 in this process. Now we'll try another example where we actually get to step 4. And I'm going to try the example of formate HCO2 minus. This is a polyatomic ion that has many atoms in it, and it has a charge. Formate is formed in hepatic liver cells, mitochondria of embryos, and in cancer cells. So, the less electronegative atom, other than, say, a hydrogen, is usually in the middle, and here they show the carbon in the middle to help us see that that's the case. So when we draw the skeleton, we're going to draw the H and the O's on the outside, and the C in the middle. That's step 1. Next, we're going to count the total number of valence electrons. Hydrogen comes in with 1, carbon comes in with 4, each oxygen comes in with 6. The -1 charge means that you have 1 extra negative electron. So anytime you have negative charges, you add more. positive charges, you would remove electrons. So that is going to give us a total of 5, 11, 17, 18 electrons for this molecule. We're going to distribute them among the atoms, trying to give everybody an octet or a duet for H. First, we make single bonds, 2, 4, 6. So out of our 18, we've used up 6. We have 12 left. Now we're going to add lone pairs. Hydrogen, of course, is good with 2. Oxygen needs 1, 2, 3, 4, 5, 6 more. Plus these 2 would give it 8. We used up 6 more. Now we have 6 left. Oxygen needs 1, 2, 3, 4, 5, 6 more to add the 2 that it's sharing to have 8. Now, I've used up all my electrons, and everybody's happy. Hydrogen has 2, oxygen 1, 2, 3, 4, 5, 6, 7, 8, and oxygen 2, 4, 6, 8. But carbon, unfortunately, is sharing 2, 4, 6. Carbon needs more. We can't just add dots to carbon because we're out of electrons. So that's where we finally get into the 4th step. If there are not enough electrons to give octets, share more by making double or triple bonds. Hydrogen can't give any more to the carbon, but one of the oxygens can take its lone pair and put those 2 electrons here, and now the oxygen and the carbon both technically have them. So oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. Now everybody has 8. Remember that this has a -1 charge. So until we learn how to tell which atom has the charge, if you want to say the charge is on the whole thing, you put brackets around it and put a negative out there.